So the last video, 7.5, is still solving trigonometric equations, but what you're going to notice is that you can't solve by factoring and you can't solve by isolating the trig function. And so what that's going to involve is using a trig identity. So if I look at this one, even if I put everything on one side equal to 0, and I said, okay, there's 4 terms, I'm going to factor by grouping. Because of that secant squared x, I'm never going to be able to find something to pull out to be left with a greatest common factor. So when you see this sort of mix, and it's not like one of the questions we did before, think, trig identities. So what I'm going to do with this is try to see if I can turn secant squared x into a tan x. So to do that, I'm going to open up my formula sheet. And I'm going to look to see if there's something I can use. Now I see a squared trig function and I automatically jump to my Pythagorean identities. In fact, if you look over here, you've got 1 plus tan squared x is equal to secant squared x. I'm like, if I do that, at least everything's going to be in tan. So I'm going to replace the secant squared x with 1 plus tan squared x. So I'm going to rewrite this as tan squared x plus 4 equals 2 times 1 plus tan squared x plus tan x. And now I'm going to see what happens. So I'm going to distribute the 2. I get tan squared x plus 4 equals 2 plus 2 tan squared x plus tan x. Okay, now I know that I can't isolate a trig function, so I'm going to make everything equal to 0 to see if I can factor to solve. So to make it equal to 0, I'm going to subtract the tan squared x from this side. I'm also going to subtract it from this side, and I'm going to subtract the 4 at the same time. Okay, I'm left with 0 on the left. I've got negative 2 plus tan squared x plus tan x. Now I'm going to rewrite this into descending orders of power. So I've got tan squared x plus tan x minus 2. Then I'm going to factor. So since this has a 1 in front, and I can see that this is a quadratic, or 3 terms, I'm going to factor using the AC, but because of that 1 in front, I'm just going to write tan x times tan x. So I'm looking for 2 numbers that multiply to give me negative 2 and add to give me 1. This is going to be plus 2 and negative 1. All right, so now that I've factored it, I'm going to set each factor equal to 0. I've got tan x equals negative 2, and I've got tan x equals positive 1. Now looking at these, one of them is going to give me exact solutions, because you always want to give exact solutions where you can, and one of them is not. So I'm going to do this guy first, because I love exact solutions. So I'm going to look at this. I'm going to go cast rule. Hopefully this starts feeling repetitive. Tan is positive in quadrant 1 and quadrant 3, right, every pi. And then it's my 1, 1, root 2 triangle. So my reference angle is 45 degrees, or pi by 4. Now, let's look back up at the question again. This time it says between 0 and 2 pi. So get rid of that 45 degrees. My reference angle is only pi by 4. There and there. Okay, so what are my 2 solutions? Well, x1 is going to be the reference angle, so just pi by 4 because it's in the first quadrant. And then the second solution is in the third quadrant, so it's going to be pi plus pi by 4. And so I'm going to write that as 4 pi by 4. Maybe if my computer will let me, 4 pi by 4, which gives me 5 pi by 4. All right, there's 2 of my solutions. Then I have to move on to where tan x equals negative 2. So tan x equals negative 2 is not one of my special triangles, so I'm going to be using my graph or my calculator to solve, but I want to look ahead to where my 2 solutions are. Tan is negative in quadrant 2 and quadrant 4. So what I want to be able to do is I want to be able to solve this with a calculator. So I'm going to go up here. I'm going to say, okay, I'm going to solve tan x equals negative 2. I just ran out of room. So we've decided, C-A-S-T, that my answer can be in quadrant 2 or quadrant 4. So what I need is the reference angle. Now if I plug in x is equal to the inverse tan of -2, it's just going to give me the negative answer, which will still be the reference angle. It'll just be in quadrant 4, but I want to answer between 0 and +2 pi. So I'm going to put it in as +2 so that I can find the reference angle. Okay, so if I do that, it's going to nicely, and I'm in radians, I'm going to go second function tan of 2. That gives me the answer of 1.1071 to 4 decimal places. So that's the answer here. Okay, this is my reference angle. So now what I want to do is get my two solutions. I want to get my solution in quadrant 2. So I'm using my subscripts in different ways, but you can do whatever you want. You can just call them x, right? Because they're both x. So the first solution is in quadrant 2. So I can do pi minus my reference angles, which is 1.1071. I'm going to store that in my calculator so I can keep doing it. So I'm going to go pi minus 1.1071. And I get one of my answers as 2.0344. And then I'm going to find the answer in quadrant 4. So I'm going to go 2 pi minus the reference angle. And I get 2 pi minus that reference angle. I get 1760. Okay, so overall, my solutions, I'll just write them in here. Overall, my solutions are, can I write those in? Actually, I could. The first answer would be pi by 4, so I was trying to figure out if I could do it in numerical order. The next answer would be 2.0344. The next answer would be 5 pi by 4. And then lastly, in the fourth quadrant, it would be 5.1760. All right, so all 4 of those answers would make this equation true. And again, plug them in and check, right? Make sure you get it. Okay. Last question of chapter 7. So this one hopefully is more of a glaring one for having to use a trig identity. And the reason it's glaring is that you're going to see sine. Sine 2x and cos 2x. So let's replace the sine 2x first, because that one's obvious because there's only one choice. Sine 2x equals 2 sine x cos x, and then I've got this sine x here, minus, I'm going to replace the cos 2x with something. Cos x is equal to negative cos x. Now these are always tricky, okay? I have to figure out which identity I'm going to replace it with. So to do that, there we go. To do that, I'm going to look through my list. So I've got cos 2x is equal to cos squared x minus sine squared x. So if I put a cos squared x minus sine squared x here, and if I distributed the cos x, I'd end up with a cos cubed x. No way. So then I'm going to look about, well, what about 1 minus 2 sine squared x? Okay, well, maybe that'll work, because if I look here, I've got 2 sine squared x cos x. So if I could get a sine squared x in there, and then I distributed my cos x through, it might work. So let's put in 1 minus 2 sine squared x and see if it works. Because again, if I had chosen the last one, which was 2 cos squared x minus 1, I think, if I distribute the cos through, I'd get a cos cubed x. So I think this is the one that's going to be a winner. So I've got 2 sine x cos x sine x, which I'm going to write as 2 sine squared x cos x. And then I'm going to distribute negative cos x through. So maybe I should write this. Never hurts to show steps. I'm going to distribute negative cos x through the bracket. Okay, so I get 2 sine squared x cos x minus cos x plus 2 sine squared x cos x. Feeling like I made the right decision, equals negative cos x. Now, because I can't isolate a trig function, I'm going to make it equal to 0 to solve. So I'm going to add cos x to each side. Add cos x, add cos x. I'm looking for that matching term. And I end up with 2 sine squared x cos x minus cos x plus cos x is gone, plus 2 sine squared x cos x. So I've actually ended up with 4 sine squared x cos x is equal to 0. Now, believe it or not, this is in factored form. It's factored because these are all multiplying. So to solve, I have to set each factor equal to 0. So I've got sine squared x is equal to 0, and I've got cos x is equal to 0. Now, to get just sine x equals 0, I'm going to take the square root, but the square root of 0 is just 0, no plus minus. So I'm solving sine x equals 0 and cos x equals 0. And again, between 0 and 2 pi. So let's start with sine x equals 0. Again, you're looking for y equals 0. So it's going to be here and here. Or you could look at your graph. Sine x, oh, not again, right? The other one was cos, is here and here. So my answer would be x is 0, right? 0, and here at pi. Sorry, so picky. I don't like that equal sign. Equals 0 and pi. Okay, and then we're going to look at where it is cos x equal to 0. This one is the one that we should remember. So it's anywhere x is equal to 0 because cos x is x over r. So it would be here and here. So that's pi by 2 and 3 pi by 2. Or again, if you're more comfortable with the graph, cos x equals 0 here at pi by 2 and 3 pi by 2. So to list all my answers, it would be 0. That doesn't look very nice as a 0. 0, pi by 2, pi, and 3 pi by 2. Those are all my solutions between 0 and 2 pi. All right, good luck with this. You're done chapter 7 almost.